guys, I am Dr. Labe, and I got my special skeleton hand with me. So YouTube gave me the job, and I'm here to introduce you. I need this to show you the human body. And we're going to talk about something that I wanted to talk to you about, got fans on YouTube. The human body.
What's the human body?
A human, we're going to rip this human up.
No, you can't.
I'm just pretending. We're going to rip this human up. We're going to rip this human up. And we're going to see what's in her. We're going to learn about the bones and how they're getting pulled on by joints. Some of the influence of the teeth and joint influence. Also learn how joints grab one another. So let's get on with the book, and I'm going to need a fan, this fan over here, to turn this way. Ow! So I'm just going to get this fan to hold the iPad up, because it's not really going well. Okay, so I'm actually going to read this Human Body Primary Explorers book to you. So I'll give you, this is pretty cool. So, I've been intelligent. So, let's get on. Okay, so this is the first page that we're reading. I haven't already done it today, so I don't know what I'm doing. But this is what I want to read to you guys. I'm going to start by doing the musculoskeletal system. But first I want to show you the introduction. Your alien body. The human body is an amazing and complicated place, both inside and out. It looks like a powerful machine with bones, muscles, nerves, organs, and tissues, all helping to keep us alive. The fuel that keeps our body going comes from food, water, and oxygen, and the air we breathe. Without these things, our bodies can't work properly. Our bodies can't work properly, and we quickly become ill. What you doing? Each part of your body has its own particular job. From muscles that help us walk, blink, chew, and play sports, to organs that let us sing or watch TV. Even when we're asleep, our body is busy breathing, growing, and repairing itself. Many parts of the body work together in groups, so we can do clever and more complicated things. Right now, for example, you're using your muscles to hold this book, your eyes to read the words, and your brain to understand the words. Made of water. More than half of your body is made of water. But some of it's lost every time we breathe, sweat, or go to the toilet. It's important to replace the lost water by drinking lots every day. Did you know the human body has more than 20 internal organs, including the heart, brain, lungs, and liver? Most of them are found in the abdomen between the chest and the hips. The bones that make up the skeleton are tough and hard-working. They support and protect the rest of the body. Okay, so we finished one page to the next. Parts of the body. People come in all shapes and sizes. Some are tall and skinny, others are short and round. Different races may have dark or fair skin, straight or curly hair, blue or brown eyes. We can have big teeth, squashy noses, long fingers, or long ears. But even though we look different, everyone has the same body parts and features. And the soft part of the body between the skin and bones is called flesh. It's made up of fat, tissue, and muscles. Under the skin are sheets of muscles. They're made up of light and dark strands, and are sometimes called strands, which means stripy. Did you know scientists who study the structure of human bodies are called anatomists? They learn by examining skeletons of real people, as well as from books. Okay, next we have a pal skeleton. This is really cool. I like a pal skeleton. He's been a pal since 1979. So, let's read about it. The skeleton. The human body is held together by a strong framework of bones called a skeleton. The skeleton supports our muscles and protects our organs. More than a dozen bones protect our brain, and 12 present limbs form a cage around our heart and lungs. As well as protecting our organs, the skeleton plays an important part in allowing us to move. The bones form levers, which muscles pull to move different parts of the body. Did you know a baby skeleton has more than 300 bones, but an adult has only 206? This is because some of the bones fuse together as the body grows. A joint. A movable joint is where two or more bones join together, but do not actually touch. They allow the skeleton to move. The hinges in knees and elbows, the bone sockets in hips and shoulders, the gliding in wrists and ankles, and saddles on the thumbs. The lower jaw bone holds the lower teeth in place. It's the biggest, strongest bone in the face and the only large bone in the skull that can move. The only saddle joint in the body is in the thumbs. It allows the thumbs to move back and forth and from side to side with limited rotation. A ball and socket joint, such as the shoulder joint, allows one bone to rotate at almost any angle to the other bone. The knee is a hinge joint. It looks like a door hinge, lowering its wing or lower leg forwards and backwards. Your ankles and wrists have gliding joints. These allow the bones to slide past each other. The spine. Our spinal backbone allows us to bend, twist, and stand upright. It supports our head and helps us keep our balance as we move around. Rather, it's being a single long bone, it's made up of 33 separate bones called vertebrae. These are shaped like rings and together they protect the delicate spinal cord. Cells are sometimes called the building blocks of life. They are the smallest living things on Earth, and when joined together, make up all larger living things. Plants, animals, and humans, each part of your body is made from cells. They come in different shapes and sizes, and all have their own special job to do. Cells are very sensitive. Cluster of cells. Some of the cells in the body don't live for very long. When they die, the rest of the cells need to replace them. To do this, they divide or split themselves in half. So one old cell becomes two new cells. Two new cells then divide and become a cluster. Bones and cells. The bones that make up the skeleton are strong, living, and full of living cells. When you see a real skeleton or bones in a museum, they look dry, crumbly, and dead. But living bones inside your body are very different. They're busy growing and changing just like the rest of you. Clever cartilage. When you're born, some of your bones are made of a firm but flexible material called cartilage. As you get older and grow, most of the cartilage becomes hard and turns into bone. Some of it stays soft and can be found in joints, where it stops two bones from rubbing against each other. You can also feel small amounts of cartilage at the top of your ears and at the tip of your nose. Tendons join muscle to bone. The calf muscle is a skeletal muscle. When the muscle squeezes, it becomes shorter. This pulls the bones closer together and forces the joints to bend. Muscles are attached to bones by bands of strong, stretchy tissue called tendons. These are similar to ligaments, which join one bone to one another, and fascia, which connect the different muscles together. The cells in the muscle are arranged in tube-shaped bundles. They slide smoothly past each other when we squeeze and relax our muscles. This slides really past each other when we squeeze and relax our muscles. Fat cell. When we eat, our body turns the food into energy. If we don't use all the food and energy straight away, it's stored in special fat cells called lymphocytes. Bone marrow. Inside the heart, outer layer of many bones, is a hollow space that helps to keep the skeleton light. It contains a soft gel-like material called bone marrow. A small amount of the bone marrow is yellow and contains fat cells. But most of it's red. The red bone marrow makes blood cells, which carry oxygen all around the body and also help us to fight germs and disease. The outer surface of the bone is called the posterior. It's made of nerves and blood vessels. Muscles and tendons attached to the posterior. Okay, then I'm going to stop with the. Do you notice the smallest and latest bone in the body is the stapes or stirrup bone? It's found in the middle part of the ear and it's about the size of a short grain of rice. So,